Right. So in today's session, I would like to discuss about remainder theorem and factor theorem. So we discussed few questions in factor theorem. So let's see. So the first question. So this is the remainder theorem. I'll explain that after the first question. For the first question, we need the factor theorem. Very easy actually. Now this function. Let me name this function as f of x. What do we need? Which of the following is a factor? Which means now this curve f of x, or one can say y equals f of x, same thing. So if I want to draw this curve, right? So there can be x-intercepts, right? Like this. Not the exact shape, just a random shape. But we need factors, which means we need x values such that we need x values for that, for those x values, y value should be equals to 0. So basically those are the factors. Those are the x-intercepts. For example, let's suppose this value 2. Let's suppose 2 is a x-intercept. Then at that point, at this for this value, for this x value, y equals to 0. In other words, when x equals to 2, y equals to 0. Y equals to 0 same as f of x equals to 0. So when x equals to 2, f of x equals to 0. In other words, f of 2 equals to 0. Right? How that is possible? To get this result, definitely we should have a factor like x minus 2 inside f of x. So that's the idea. So these two things are quite important. So if f of 2 equals to 0, then you will get a situation like this. Hence, you will see x minus 2 factor inside f of x. And also the other direction. When x minus 2 is a factor, x equals 2 is an x-intercept. Like that. Now, how would you apply this concept for this question? That's the most important thing. So we need these values. Values like basically these values. There can be more, can be less. But the most important thing is finding those values. What do we know about those points? What do we know about these points? For these x values, f of x or y equals to 0. That's what we know. Right? So if you can compute those x values, then you can compute factors very easily. So for that, let's try these values. So for example, for this value, for x minus 3, if I express factor theorem for that, it's like this. X minus 3 is a factor, then f of 3 equals to 0. Those are the two statements. From factor theorem, using factor theorem, we connect these two. If x minus 3 is a factor, f of 3 equals to 0. And also the other direction. If f of 3 equals to 0, x minus 3 is a factor of f of x. So now for this question, I think we want to determine whether x minus 3 is a factor or not. Hence, I think we should follow this path, this direction, isn't it? Because we want to determine whether x minus 3 is a factor or not. So for that, you can check f of 3. Because if f of 3 equals to 0, according to the factor theorem, x minus 3 is a factor. Right? Because you can't follow this direction, because how do you know whether x minus 3 is a factor or not? Don't know that, right? That's what we want to determine. Hence, we should start that side. So now we just need to check whether f of 3 equals to 0 or not. That's what we want to check. Because if f of 3 equals to 0, then x minus 3 is a factor. If f of 3 does not equals to 0, then we are talking about a different y value. That's not 0. Hence not a x-intercept. Therefore, x minus 3 is not a factor. So let's check that. So this is the function. Now let's compute f of 3 because we want to check this condition. Right? F of 3. I just replace each x by 3. Now don't even need to compute. The question is whether this part equals to 0 or not. What do you think? Clearly, these three values greater than 6. So that value minus 6, definitely you will get a positive value for this part. Positive value greater than 0. Hence, f of 3 does not equals to 0. If you want to, you can simplify, that's not a problem. But that's not necessary. 27 plus 4 times 9, 36 plus 3 minus 6, that's here minus 3, 36 minus 3, 33. So 27 plus 33, that is I think 60, does not equals to 0. Therefore, x minus 3 is not a factor of f of x. Similarly, try all the other factors. Then you can try x minus 1. For that, just need to change this statement. Let me write this one. Instead of x minus 3, now we are working with x minus 1. Here f of 1. That's all. Just check whether f of 1 equals to 0 or not. Right? For that, you can replace that x by 1. Then check that. Then, but for some cases, for some values like x plus 4 or x plus 1, it's slightly different. Right? Now, if I write that factor theorem for a value like, let's say, x plus 3, now it's different now. the way of writing is quite important. Now x plus 3, it's a factor of x, factor of f of x. Then what's the corresponding value? F, not, that's not f of 3, right? Because we should create that minus sign here. So I'm going to write x plus 3 as x minus minus 3. Because we need that form, because that's the factor theorem. You might remember. If x minus c is a factor of f of x, then f of c equals to 0. That's the factor theorem. Right? Both directions. You can follow both directions, this one or this one. But the idea, creating this minus sign is very important. Right? So that's why we change this plus sign to minus. We can do that, right? Because plus 1 equals to minus 1 times minus 1. That's what I did. I replaced this plus sign by these two minus signs, multiplication. Then basically we are dealing with x minus minus 3 is a factor of f of x if f of this value. Can you see that? F of minus 3 equals to 0 or not. That's what we are going to check. So that's the factor theorem for x plus 3 for this part. But for, yeah, for x plus 3, right? That's very important because x plus 3 same as x minus minus 3. That's the idea. Always create that minus sign. Very important. Like that. So for x minus 3, we previously wrote for x minus 3 here. It's just 3 here and 3 here. But for plus 3, you should change that slightly. Okay, that's the idea. With that understanding, you should be able to determine whether x plus 4 and x plus 1 are factors or not. For this one, x minus minus 4. Therefore, check f of minus 4, whether that one equals to 0 or not. And for this one, x minus minus 1, check whether f of minus 1 equals to 0 or not. You can check those things. That way, we can solve this problem. Once again, focus on that minus sign, very important.